This is an extension of substitution, and now we're going to have defined limits on the integral. It'll no longer be indefinite, but it will have an upper and lower limit, and we'll see how to deal with that. So let's begin, just as before, by thinking about what we're going to do. Certainly we could expand 3t minus 1 to the 50th power. It would become 51 terms. It would be very unwieldy. That is not the way to go. So what we're going to do is use a u substitution. We're going to let u equal 3t minus 1. Now, this provides for us another way of writing the limits. In other words, this is a translator to put anything that's written in t into u. For example, notice our upper limit is 1. When we put in 1 for t into this little expression, we can calculate what u is. And u, of course, is 3 minus 1, or u is 2. And when we put the lower limit in, 0, we can now make a calculation that u is going to be negative 1. So we're going to recast not only the integrand, not only the operator written in u, but we're also going to recast our upper and lower limits. So think about the derivative here, du. Wouldn't it be 3 dt, dt, 3 dt, and wouldn't that suggest that 1/3 of a du is the same thing as a single dt? So making all our substitutions now, let's take out our dt and write in its place 1/3 du. Let's take out our integrand, 3t minus 1, and replace it with u and raise u to the 50th. And now it seems that we have a rather reasonable looking problem. And the great thing is, if we replace the limits with new limits, we don't have to return to the old limits. We don't have to return and back substitute. We can just solve this new problem, and its answer will be the same as the original. So I'm going to install my limits, negative 1 for my lower limit and 2 for my upper. So solving this problem out, won't we get 1/3 times u to the 51st over 51? And my upper and lower limits are 2 and negative 1, respectively. So if I go and put my upper limit in, won't I get 2 to the 51st power over 51? 2 to the 51st is a huge number. Don't even try to do anything with it. Just leave it. And then won't I subtract from that, subtract from it a negative, and subtracting a negative will result in adding. Minus a minus is a plus. And won't it become plus a 1 over 51 for my lower limit? And there is your answer. 42 is done. Let's look at another. Number 48 looks rather ominous, but jump in and see how this goes. I'm going to suggest that we start with a u substitution, and although it looks like a bit of a coin flip, I'm going to go with u equaling the sine of x. The derivative, of course, of sine is cosine, and I'm going to think about my limits right away. My upper limit, when in the x problem, the upper limit is pi over 2. Well, in a problem written in u, using that opening substitution, I can see that u would equal the sine of pi over 2, and the sine of pi over 2 is 1. And that lower limit in the x problem, Over on the left, that lower limit is 0, so when x is 0, doesn't it suggest that u equals the sine of 0, and the sine of 0 is 0? So now it seems to me that I have enough information to write my problem in u. So here we go. The integral and my upper and lower limits are 1 and 0 respectively. Then I'm going to say my du covers cosine of x and dx. The first and the last part, the cosine of x and the dx, those two things are replaced by my du. So I'm going to write that on the end. And what do I have left? Well, I have left the sine of x, but remember, the sine of x is u. So now, don't I have this rather simple problem, the integral of the sine of u du? So I'm going to evaluate the integral of the sine of u, or take the antiderivative, and that, of course, is negative cosine u. And I've got these new limits written for this problem u. So I'm going to use 1 and 0 now. I'm not going to back substitute. I've already got limits that will work for this problem. So won't it be the negative cosine of 1 minus the negative cosine of 0? And minus a minus will make it plus. So it'll be the negative cosine of 1 plus the cosine of 0. And isn't that the negative cosine of 1 plus 1? Because the cosine of 0 is 1. So probably most people would turn this around and write the 1 first and write 1 minus the cosine of 1 as the final answer. For the last example, I've chosen number 56, maybe just because it looks ugly, and maybe you would be intimidated by such a problem, but let's take it apart and see what we can do with it. First of all, that whole expression inside the parentheses, let's be very clear about what that is. It is 2 pi little t over big T minus alpha. And I know that little t is the only variable. Everything else is a constant. Pi, of course, is a number, but big T and alpha are constants. So think about that numerator once again, where it says 2 pi t over big T. Couldn't I write it as a 2 pi t out front of little t, like a coefficient in front of little t, minus my alpha? Isn't that what u is? So when I come along and take my derivative, won't I get just 2 pi over t minus 0, or just 2 pi over t dt? And so wouldn't this suggest that if I multiply both sides by t over 2 pi, I would get dt, a replacement for dt? So I'm going to jump in and take my dt out and write t over 2 pi du in its place. Before I do that, let's consider our upper and lower limits. So when my upper limit is t over 2, when little t in the t problem is big T over 2, using my first line, my u translator, wouldn't u equal 2 pi over t times little t, which now is t over 2, subtracting alpha? And won't the big T's cross? Won't the 2's cross? Won't I be left with pi from the first term and a pi minus alpha? Isn't that my new upper limit when the problem is written in u? And similarly, my lower limit, when I put in 0 for the t problem, won't u equal 2 pi over t times 0 minus the alpha, and therefore 0 minus alpha is just a negative alpha. So now I have my new upper and lower limits, and now let's write out the new problem. So upper and lower limits, pi minus alpha and a negative alpha. Pi minus alpha upstairs, negative alpha in the lower limit. And then won't it be the sign of, and didn't I replace everything in the parentheses with u? So it'll be the sign of u. And didn't I say dt was the same thing as 2t, big T over 2 pi du? I'll kick that constant t over 2 pi way up front and then write my du. And now I have a very doable problem. It's going to start with that t over 2 pi in the answer. And now the antiderivative of sine of u is negative cosine of u. But I'm going to go right ahead and put in my upper limit, which is pi minus alpha. And then I'm going to have minus, and won't it be minus a minus, because we're talking about negative cosine, so minus a negative cosine will be plus a cosine of my lower limit, which is negative alpha. And that's it right there. Cosine is what we call an even function, so the cosine of negative alpha is the same as the cosine of alpha. So most would write this final answer as t over 2 pi and say, well, let's bring that positive term to the front. Cosine of alpha is the same thing as the cosine of negative alpha, and then subtract from it the cosine of the quantity pi minus alpha. And that would be our final answer. So with these examples, I hope that you would be able to move on and go to page 382. So we're going to go to 382 now, is where the assignment will continue. And we're going to do 41 to 57, the odds. And this is what we'll talk about next time.